Let us study about some basic concepts of this chapter. Complex numbers. Complex numbers are defined as expressions of the form a plus iota b, where a and b belong to set of real numbers and iota equals under root of minus 1. It is denoted by z, that is, z equals a plus iota b. A is called the real part of z and b is called imaginary part of z. Every complex number can be regarded as any of the three following types: purely real if b equals 0, purely imaginary if a equals 0, and imaginary if b equals 0. Note that the set R of real numbers is a proper subset of the complex numbers. 0 is both purely real as well as purely imaginary, but not imaginary. Iota equals square root of minus 1 is called the imaginary unit. Let us take another example. If x plus 2y plus iota times 2x minus 3y equals 5 plus iota into minus 4, where x and y are real numbers, then find x and y. Let us see the solution. We have x plus 2y plus iota times 2x minus 3y, which is equal to 5 plus minus 4 iota. Equating the real and the imaginary parts of equation 1, we get x plus 2y equals 5 and 2x minus 3y equals 4, which on solving simultaneously, we get x equals 1 and y equals 2. Let us study about integral powers of I. Let us observe the integral powers of I. We have iota equals under root of minus 1. Let us start with integral power 0. We have learned that any number raised to the power 0 is 1. This applies to imaginary numbers as well. Therefore, iota raised to the power 0 equals under root of minus 1 raised to the power 0, which implies iota raised to the power 0 equals 1. We have also learned that any number raised to the power 1 is the number itself. This also applies to imaginary numbers. Therefore, iota raised to the power 1, which means under root of minus 1 raised to the power 1, is equal to iota. Therefore, iota raised to the power 1 equals iota. Let us square both sides. Iota square equals under root of minus 1 square, which implies iota square equals minus 1. Now, let us observe for integral power 3. Iota raised to the power 3 equals under root of minus 1 raised to the power 3. This could be written as iota cube equals under root of minus 1 square into iota. Since we know that iota square equals minus 1, that is why iota cube equals minus iota. Now, let us observe for integral power 4. Iota raised to the power 4 equals under root of minus 1 raised to the power 4. This could be written as iota raised to the power 4 equals under root of minus 1 cube into iota. Since we know that iota cube equals minus iota, therefore iota raised to the power 4 equals minus iota into iota, which implies iota raised to the power 4 equals minus iota square, which further implies iota raised to the power 4 equals negative of negative 1, since iota square equals minus 1. This gives iota raised to the power 4 equals 1. Now, let us observe for integral power 5. Iota raised to the power 5 equals under root of minus 1 raised to the power 5. This could be written as iota raised to the power 5 equals under root of minus 1 raised to the power 4 into iota, which implies iota raised to the power 5 equals 1 into iota, because we know that iota raised to the power 4 equals 1. This gives us iota raised to the power 5 equals iota. Now, let us observe for integral power 6. Iota raised to the power 6 equals under root of minus 1 raised to the power 6. This could be written as iota raised to the power 6 equals under root of minus 1 raised to the power 5 into iota. This implies iota raised to the power 6 equals iota into iota, since we know that iota raised to the power 5 equals iota. This implies iota raised to the power 6 equals iota square. This implies iota raised to the power 6 equals minus 1, since we know that iota square equals minus 1. Now, let us observe for integral power 7. Iota raised to the power 7 equals under root of minus 1 raised to the power 7. This could be written as iota raised to the power 7 equals under root of minus 1 raised to the power 6 into iota. This implies iota raised to the power 7 equals minus 1 into iota, since we know that iota raised to the power 6 equals minus 1. This gives us iota raised to the power 7 equals minus iota. We can observe that there is a cyclic pattern in values of iota raised to integral powers. We can deduce that for any integer k, iota raised to the power 4k equals 1. Iota raised to the power 4k plus 1 equals iota. Iota raised to the power 4k plus 2 equals minus 1. Iota raised to the power 4k plus 3 equals minus iota. Note that we have said integers, not whole numbers here. So, let us check if this holds true for negative integers as well. Let us observe the negative integral powers of iota. Iota equals under root of minus 1. Let us start with integral power minus 1. Let us divide both sides by iota square. Iota by iota square equals iota by minus 1, since iota square equals minus 1. This implies iota raised to the power minus 1 equals minus iota. Now, let us observe for integral power minus 2. Dividing both sides by iota cube, we get iota by iota cube equals iota by minus iota, since iota cube equals minus iota. This implies iota raised to the power minus 2 equals minus 1. Now, let us observe for integral power minus 3. Dividing both sides by iota raised to the power 4, we get iota by iota raised to the power 4 equals iota by 1, since we know that iota raised to the power 4 equals 1. This gives us iota raised to the power minus 3 equals iota. Now, let us observe for integral power minus 4. Dividing both sides by iota raised to the power 5, we get iota by iota raised to the power 5 equals iota by iota. Since we know that iota raised to the power 5 equals iota, this implies iota raised to the power minus 4 equals 1.